Before we begin, take a breath with me and imagine this. Imagine a time before Earth had oceans, before mountains reached for the sky, before even the sun was fully born. Imagine silence so deep that time itself felt empty. Welcome back to Earth's Archive, the place where we don't just learn about our planet, we travel through its memories. If you've ever looked at the night sky and wondered how this spinning world beneath your feet came to exist, then stay with me, because this story begins not on Earth, but in the dust between the stars. So let me ask you something. Have you ever held a grain of sand in your hand and really looked at it? One tiny grain, almost meaningless on its own. Now imagine trillions upon trillions of those grains floating through space. That is where our story starts. Earth, every rock, every ocean, every living thing including you, began as cosmic dust drifting in the cold darkness of the universe. Around 4.6 billion years ago, long before there were planets, there was only a vast cloud of gas and dust spread across space. This cloud was not dramatic. It didn't glow or shine. It was quiet, invisible, and enormous. It was made of hydrogen, helium, and tiny dust particles forged in the hearts of ancient stars that had lived and died before our sun ever existed. Those stars exploded in supernovae, scattering their remains across the galaxy, and those remains would one day become Earth. Something disturbed that peaceful cloud. Scientists believe it may have been a nearby supernova explosion or the passing shockwave of another forming star. Whatever it was, gravity began to take control. The cloud started to collapse in on itself. As it collapsed, it began to spin. Slowly at first, then faster and faster. At the center of that spinning cloud, pressure and heat increased until a new star was born. That star was our sun. Around the newborn sun, the remaining dust and gas flattened into a spinning disk. This was the solar nebula, a cosmic construction site. Inside this disk, tiny dust particles began to collide. When they collided, they stuck together. At first, these clumps were microscopic. Then they grew into pebbles. Pebbles became rocks. Rocks became massive bodies called planetesimals. All of this happened over millions of years, driven by gravity and motion. Within this swirling disk, different regions formed different worlds. Close to the sun, where it was hot, only metals and rocky materials could survive. Farther out, where it was colder, ice and gas dominated. Earth formed in that inner region, where rock ruled and fire shaped everything. The young Earth was nothing like the planet we know today. It was a molten world, a glowing sphere of magma constantly bombarded by asteroids and debris left over from planet formation. The surface was a sea of fire. Volcanoes erupted endlessly. The sky was thick with toxic gases. There was no oxygen, no oceans, no life. Yet even in this chaos, the foundations of our world were being laid. As Earth grew larger, gravity pulled heavier elements like iron toward its center. This process, called differentiation, created Earth's layered structure. The iron sank to form the core. Lighter materials rose to form the mantle and crust. This separation generated heat and movement inside the planet, movement that still drives earthquakes and volcanoes today. One of the most dramatic events in Earth's history happened during this early time. A Mars-sized object, often called Theia, collided with the young Earth. The impact was so powerful that it blasted enormous amounts of material into space. That debris eventually came together to form the Moon. The Moon stabilized Earth's tilt, controlled the tides, and played a critical role in making Earth habitable. Without that collision, life as we know it might never have existed. After the chaos of formation began to settle, Earth slowly cooled. The surface hardened into crust. Volcanoes continued to erupt, releasing gases trapped inside the planet. These gases formed Earth's first atmosphere. It was thick with carbon dioxide, nitrogen, water vapor, methane, and ammonia. Still no oxygen. But something incredible was about to happen. As Earth cooled further, water vapor condensed. Rain fell for thousands of years. Imagine rain falling on hot rock for centuries without stopping. Those rains filled the low areas of the crust and formed the first oceans. Earth, once a world of fire, became a world of water. Inside those ancient oceans, chemistry began to experiment. Simple molecules combined into more complex ones. Energy from lightning, volcanic heat, and the sun powered reactions that slowly built the building blocks of life. Somewhere in those oceans, the first self-replicating molecules formed. Life had begun. At first, life was simple. Single-celled organisms ruled the planet for billions of years. But these tiny life forms would change Earth forever. Some of them learned to use sunlight to make energy through photosynthesis. In doing so, they released oxygen as a waste product. Over millions of years, oxygen accumulated in the atmosphere, triggering the Great Oxygenation Event. Oxygen was toxic to much of early life, but it also made complex life possible. It allowed cells to produce more energy, leading to the evolution of multicellular organisms. The sky turned blue. Ozone formed, protecting the surface from harmful radiation. Earth was transforming. Continents formed and broke apart. Ice ages came and went. Asteroids struck. Volcanoes reshaped the surface. Life adapted, evolved, and survived. From simple cells to plants, animals, and eventually humans, all of it traces back to cosmic dust drifting through space. And here's the part that should really stop you for a moment. The atoms in your body were forged in ancient stars. The iron in your blood, the calcium in your bones, the oxygen you breathe all came from stellar explosions billions of years ago. You are not separate from the universe. You are the universe, aware of itself. Every mountain, every ocean, every living thing is a chapter in Earth's story. And Earth's story is written in stardust. When you walk on the ground, you're walking on the remains of stars. When you look at the night sky, you're looking back at your own origins. This is why Earth is not just a planet. It is a living archive of cosmic history. From dust to fire, from fire to water, from water to life. A story billions of years in, the making, still unfolding beneath our feet. If this story made you see Earth differently, if it made you feel a little smaller but also deeply connected to everything around you, then this channel is for you. Earth's archive exists to uncover the hidden stories of our planet and our universe, one journey at a time. If you enjoyed this video, make sure to like it so more people can discover Earth's story. Subscribe to Earth's archive for more deep journeys into the past of our planet and the cosmos. And tell me in the comments, when you look at the stars tonight, what will you be thinking about? Until next time, remember this. You didn't just come from Earth. Earth came from the stars. And so, did you? Now, let's slow this moment down even more, because the early Earth was not just forming in isolation. It was part of a violent neighborhood. The young solar system was chaotic, crowded, and unstable. Planets were still shifting their orbits, asteroids crossed paths unpredictably, and massive impacts were common. Earth was struck again and again by space rocks ranging from mountain-sized to continent-sized. Each impact reshaped the planet, melting its surface, cracking its crust, and mixing its materials. This era is known as the heavy bombardment, and without it, Earth would not be what it is today. Every collision delivered something new. Some brought metals. Others brought carbon-rich compounds. Many delivered water locked inside minerals and ice. For a long time, scientists debated where Earth's water came from. Was it already here, or was it delivered later? Today, we believe it was a combination of both. Water existed deep within Earth's materials, and more arrived aboard icy. Asteroids and comets that struck the planet over millions of years. Drop by drop, ocean by ocean, Earth became blue. As the surface cooled and solidified, the crust began to crack into massive plates. These plates floated atop the semi-molten mantle below. Slowly, almost imperceptibly, they moved. When plates collided, mountains rose. When they pulled apart, magma surged upward to create new crust. This process, plate tectonics, became one of Earth's most important systems. It recycled materials, regulated temperature, and created diverse environments where life could evolve. Imagine standing on early Earth during this time. The sky would look nothing like it does today. The sun would appear dimmer, glowing through thick clouds of gas. The air would smell of sulfur and smoke. Lightning would crack constantly across the sky, striking the surface with raw energy. Volcanoes would dominate the horizon, pouring lava into the sea. And yet, beneath the waves, something extraordinary was happening. In the warm, mineral-rich waters near hydrothermal vents, chemistry became complex. These vents released heat and nutrients from Earth's interior, creating natural laboratories, where molecules could assemble, break apart, and reassemble again. Over time, structures formed that could copy themselves. This was the birth of biology. Not sudden, not dramatic, but persistent and unstoppable. Life did not conquer Earth overnight. For billions of years, it remained microscopic. But those tiny organisms reshaped the planet in ways nothing else ever had. They altered the chemistry of the oceans. They changed the atmosphere. They built reefs, sediments, and eventually entire ecosystems. Earth and life became partners, evolving together. As oxygen slowly accumulated, iron in the oceans reacted and settled onto the seafloor, forming vast banded iron formations that we still mine today. These rocks are physical evidence of life's impact on the planet. Proof that biology and geology are inseparable. With oxygen in the air, energy became more abundant. Cells grew more complex. Some learned to cooperate, forming multicellular organisms. Others developed hard shells, eyes, and the ability to move. Life exploded in diversity during events like the Cambrian explosion, filling the oceans with strange and wonderful creatures. Meanwhile, Earth itself continued to change. Continents drifted, collided, and separated again. Supercontinents formed and broke apart. Each rearrangement altered ocean currents, climate, and habitats. Ice ages locked water into glaciers, lowering sea levels and reshaping coastlines. Then, warming periods melted the ice, flooding the land once more. Life adapted every time. Asteroid impacts didn't stop either. Some were catastrophic. One impact around 66 million years ago ended the age of the dinosaurs. But even this destruction opened the door for mammals to rise, eventually leading to us. Earth's history is not a straight line of progress. It is a cycle of creation, destruction, and renewal. And through all of this, Earth remained balanced in a delicate way. Not too close to the sun, not too far. Large enough to hold an atmosphere, but not so large that it became a gas giant. Protected by a magnetic field generated by its molten core, shielding life from deadly radiation. Stabilized by the moon, keeping seasons predictable. Every factor mattered. When you step back and look at the full picture, it feels almost impossible. A universe filled with chaos somehow produced a planet capable of life. But this wasn't luck alone. It was physics, chemistry, time, and persistence working together across billions of years. And remember this: Earth is still forming. Mountains are still rising. Oceans are still shifting. Life is still evolving. The story did not end with us. We are just one chapter in a book that began with dust. This planet beneath your feet has survived fire, ice, impacts, and extinction. It carries the memory of stars in every atom. And it carries us, too, conscious beings capable of asking where we came from. As we continue this journey deeper into Earth's archive, keep this thought with you. You are not standing on something ordinary. You are standing on a miracle shaped by time. And now, as we begin to bring this chapter of Earth's story closer to a resting point, let's widen our view one last time. Think about how fragile this entire process truly was. One slightly different orbit, one slightly weaker magnetic field, one missing moon-forming impact. And Earth could have ended up lifeless, like so many other worlds drifting silently through space. Mars once had rivers. Venus may once have had oceans, but something changed. Mars lost its magnetic field and its atmosphere was stripped away by the solar wind. Venus experienced a runaway greenhouse effect that turned it into a furnace hot enough to melt lead. Earth balanced on a knife's edge between these extremes. Not because it was destined to, but because countless conditions aligned. Just enough, for just long enough to allow life to persist. Earth learned to regulate itself. Carbon moved between air, ocean, rock, and life. Temperature stayed within a survivable range. Ice reflected sunlight. Forests absorbed carbon. Oceans stored heat. Life didn't just exist on Earth, it became a part of Earth's operating system. And then, very recently in cosmic terms, humans appeared. Creatures made of star stuff who learned to look back at the universe and ask questions. We learned to read rocks like history books. We learned to decode light from distant stars. We learned that the same physical laws shaping galaxies also shaped our bones and blood. Right now, as you listen to this, Earth continues its ancient motion, spinning once every 24 hours, orbiting the Sun at 30 kilometers per second, carrying every living thing through space together. We are passengers on a planet born from dust, shaped by fire, cooled by rain, and awakened by life. So, the next time you feel small, remember this. Small things built everything. Dust became planets. Molecules became minds. And one ordinary world became a home. This is Earth's origin story. But it is not the end of Earth's story. In the next video on Earth's archive, we're going to travel even deeper into the mystery and ask a powerful question. Why is Earth alive while most planets are dead? We'll explore the rare conditions that make a planet habitable, the invisible shields that protect life, and whether worlds like ours might exist somewhere else in the universe right now. If you don't want to miss that journey, make sure you're subscribed. Like this video if it made you see Earth differently. Share it with someone who looks up at the night sky and wonders where it all began. Because this archive is far from complete. Until next time, remember this: you are standing on the memory of the universe itself.